So we've learned that the volcanoes actually cool the surface temperatures. So is it possible maybe that we could use this to actually offset global warming? Well, some people claim an area of research called geoengineering, where we can actually try to fix the climate, that we can use our knowledge about volcanoes to try to offset the increasing temperatures we're seeing around the planet. And one idea is we could take planes or other methods and we could actually deposit these gases, the sulfur dioxide, the same way the volcano puts sulfur dioxide at 20, 30 kilometers. We can just take it there, the gas, by an aircraft, by balloons. We can put it in the upper atmosphere. And then naturally, as the nature does it after a volcano, the sulfur dioxide will be converted into these tiny droplets of sulfuric acid. It will reflect the sunlight back to space and will cool the surface of the Earth. So how could we do that? Well, there are different ways we could get that gas up into the upper atmosphere. One of them is shown here, where we can have a tethered balloon, a balloon which can go up to maybe 30 kilometers, can release the gases in the stratosphere, and then again, naturally, nature will produce the sulfuric acid and will produce this very thin screen in the upper atmosphere, which will block out some of the sun's rays. We can also take it up by planes. Some people have suggested even with a kind of a rocket, sending up a canister of this gas and releasing it up in the upper atmosphere. And as we've seen in this lesson, the effect will be maximum at maybe 6 months to a year after we start this process. So it may react fairly quickly. As soon as we start putting the gas up in the stratosphere, within 6 months to a year, we'll see effects on global temperatures. And if we turn off the switch and we remove the source of sulfur dioxide, it will also disappear within, say, 1 to 2 years. And so this can be reversible, and we can maybe decide how much to put, when to put, where to put, etc. In the atmosphere. Again, the idea is that naturally, when we have stratospheric aerosols in the atmosphere from volcanoes, this cools the climate, it reduces the amount of sunlight coming into the surface, and we could maybe do this artificially by taking planes up there, flying and putting the same gases into the upper atmosphere that volcanoes put, and this will then result in this screen of particles around the planet, which will actually cool the surface. Well, if we try to simulate this, we can see here on the right-hand side what we expect to be due to global warming, looking down on the North Pole. So this is looking at the northern hemisphere. You can see maybe North Africa at the bottom and United States on the left, but in the center is the North Pole. And this shows the warming that we can expect in the future on the top, and the changes in rainfall in the bottom right if we don't use this geoengineering. And what we see is what we've spoken about throughout the course, that we expect to see increasing temperatures with an amplification of the temperatures over the pole. The Arctic is going to warm a lot more than the rest of the planet. And when we look at the rainfall in the bottom right plot, the greens show that in the northern latitudes, in northern Canada, Asia, Europe, we expect to see much more rainfall than we see today. But in the lower subtropical regions, like in the Mediterranean and other parts of the subtropics, we expect a decrease in the rainfall. Well, now if we put some of the sulfur dioxide into the atmosphere and we run the models again, because of the production of these small particles, the result of the warming and the change in rainfall is shown on the left. So on the left, the top left, we see the changes in temperature in the future if we use this geoengineering with aerosols in the stratosphere, and we see a dramatic decrease in the temperatures. We still have some warming over the poles, but we actually have cooling in other regions, and if we average this all together, the warming could be close to zero. And if we look at the rainfalls, we also have less extreme changes in the rainfalls in this simulation. However, we have to be careful. What we're doing here with this experiment, and luckily this is an experiment on the computer, but by cooling the planet, we can also, and putting aerosols in the stratosphere, we can also change the circulation patterns in the atmosphere and rainfall patterns in parts of the world. And countries, especially the developing world, which rely on rainfall for their crops, for them, rainfall may be a lot more important than temperature. And if you cool the planet, but you reduce the amount of rainfall, say in Africa, this could have huge detrimental impacts on food security and other aspects. And there may be many surprises also that happen that we're not aware of. But maybe more important is that this only impacts the temperature. It doesn't have any effect on the carbon dioxide in the atmosphere. And we know, we've spoken about the oceans, that carbon dioxide increases in the atmosphere are impacting the acidification of the oceans, which are affecting coral reefs and biology in the oceans. And so by just dealing with the temperatures, we're not dealing with the other problems which are causing climate change. And it's very controversial, this area of geoengineering, but still it's a topic of research to keep maybe on the side in the drawer of our desks for maybe one time when, if we do have a climate emergency, then we could maybe use our knowledge related to volcanoes and aerosols in the stratosphere, which would impact the climate and then cool the climate down within 6 months to a year if needed in the future.